end user of the what and all the analysis that you have found out, and how is your model doing and what you will do. So all those things I'm going to show you today. That's the main agenda for today. So just let's quickly share my screen. Second. Let me know if you're able to see my screen. Let me know if you guys are able to see my screen.
Yes, Tanmay.
Yeah, thank you. So let's go deeper into the brief introduction of artificial intelligence and machine learning. So if you see, the AI is everywhere. You open in news, you open any company's website, everyone are trying to transform their existing applications or create new AI applications and then integrate with their codes. So there are many things that AI can do. Like it's just a newspaper articles of different articles, like how AI became this ubiquitous. Because see, executive guide to developing AI at scale. This is the Deloitte Insights paper where they have clearly had an article about AI and cognitive technologies. So and with the latest thing, there is something called cloud infrastructures. So all the cloud infrastructures like Azure, which is powered by Microsoft, and AWS, which is powered by Amazon, and Google Cloud, which is powered by Google. So all this technologies, they have integrated the AI part. So you can go to any of the cloud and build an AI application or build an AI pipelines. So there is a lot you can do with the AI. As I said in the previous class, machine learning is a subset of artificial intelligence, and deep learning is an internal subset of machine learning. So see, artificial intelligence, it is something, a program that can sense, reason, act, and adapt. Whereas machine learning, as it clearly said, it's the algorithms that performs, that do the performance, and then what we are expecting the model to do. So algorithms whose performance improve as they expose it to more data over time. So let's say you have some data today. So you ask a machine to do a task. So it kind of learn all the features, or it kind of learn all the other techniques. But tomorrow, when a new data comes, that means a new pattern is coming. So your machine could not able to predict it properly because that pattern is not being trained. So machine learning, it's a robot, it's with a blank brain. So you have to make that brain train. So as it's in our hands how you're going to train. It's in our hands how your machine should do on a vast data set. So the more the data, the more the algorithms will understand the pattern behind it. So next comes the deep learning part. Deep learning, as I said, it's a subset of machine learning in which multi-layered neural networks learn from vast amount of data. So as I said, deep learning is just like a human brain. It's like a human brain, as I said, like we how we learn by seeing things, how we read, how we remember, everything is done by deep learning. I'm going to show you the internal architecture. So on a whole, machine learning provides smart alternatives to analyze vast amount of volumes of data. Let's say you go to any vendor or someone, you go to any shop, he has lots and lots of data. So let's take an example of a supermarket. Okay, let's take an example of supermarket. So he has a sales data. So he has a customer ID. He has a customer. He has a customer. He has a customer ID, and he has all the details of what and all the items he purchased. He purchased. So how you're gonna showcase this data? So let's say a customer who has bought bread let's say 10 customers who bought bed. Out of this 10, close to 8 people took jam bottle, jam bottle. Or let's say who bought eggs, uh, eggs they more tend to take in another fruit basket or like onions or something for their omelette. So there are some relations between the features. See, bread is a feature, jam is a feature, but there is a relation, right? Out of 10 people who bought bread, 8 people are buying a jam. So let's say what the sales guy will do, he wants to make increase, so he want the other 2 people also to buy a jam. So what he'll do, he'll come up with a new plan saying bread plus jam on a combination. You get discount of some amount, 10% or something, so that he's increasing his sales. How he is getting to this decision? It's because of the data insights that we provide, the data scientists provide. So you go to a McD or you go to a McD or you go to a KFC. So if you remember, it will be a real time experience. If you guys said like someone said like you wanted to go for a burger or a, medium meal. So the person who is selling it, they'll say, sir, there is only a difference of 20 rupees or 30 rupees between medium and large. You can go for. So obviously our mind thinks 20 rupees. It's no matter. We can go. So that's the business technique that they use. How are they getting it? It's because with the previous data or with the previous thing. Let's say who has bought KFC popcorn. They most of the people they got Coke. So he'll keep an offer. Who are buying a popcorn, they can get Coke for let's say 10 rupees lesser or 20 rupees lesser. He's increasing the sales. So that's much amount of alternatives that we can provide to with the machine learning outputs, with the predicting nature, with the data insights. So there is a lot more to learn. So with these things, machine learning can produce accurate results and a very good amount of analysis, guys. So now let's see, I'll just show you two types of AI mostly. This is artificial narrow intelligence. This is artificial general intelligence. So it's just a basic terminology. Narrow intelligence means it is something limited to a specific domain. Like let's say smart speaker, your Alexa, your Google Mini, or a self-driving car, web search, AI in framing and factory. So it's specific to do a task. You have given a task, it will continue to do the same thing. So it intelligence lies in that area only. Whereas artificial intelligence, general intelligence, it's the general human, it's the actual robo, anything that human can do. So these are the main two types. Our most of the companies, everyone are relying in this, whereas some R&D teams who build like Javis, like all this, they use this artificial general intelligence, guys. So I'll just tell you a small example. Let's say this is your input and this is your output. So if you take an email, see, as I said in the previous example, like is it a spam email or a normal email? So if it is spam, if it is a if it is not a spam email, then make it 0. If it is a spam email, make it to 1. So your email is categorizing into two things, 0 and 1. And you have an audio. So you convert that to a text. Machine learning can do. You can change your language from English to Chinese. Like you give a text in English, it will convert it to Chinese. And image read or image of phone, is there any defect in the image? Add user. There are many examples. These are all supervised examples which has proper data. I have clearly told you what is supervised learning in my day one session. So just going through it. So supervised learning is something which you have a structured data. See, clarity input and clarity output. See, spam filtering, speech recognition, machine translation, online advertising, self-driving car, visual inspection. So these are all with a proper set of data sets and a proper set of outputs defined, so that you're asking your machine to perform this task, so that it is doing it systematically. So that's mainly of supervised learning. See, over the years, the amount of data is increasing day by day. So there is vast amount of data. Let's say if you go on a Twitter, or if you go on any other Facebook, WhatsApp, Google's, your search history, your data you're entering into any website, every data is not secure, guys. Even Google says if the data is secure, it's not. So as long as the data is increasing, there are different n- networks or different techniques that came into existence. Initially, you have a traditional AI which gives performance to some extent. After that, there are some small neural nets that came into existence. After that, medium. Now we have a high performance of large neural networks with the vast amount of data. So as long as the techniques are getting increased, the compute power is increasing. So the compute power, like now when you want to train a neural network, your CPU does not support. You need to have a graphical processing unit, GPUs, cloud GPU, be it a local GPU, you should have a high RAM. And that compute power with a combination of neural networks, it's a deadly combination, guys. And to this, we should be making sure that data is available. We should be making sure that the data is available. That's the main thing. Okay. So now let's see what is deep learning or neural networks does. Okay. Yeah, sorry. So now, as I said, these are neurons. I'm going to tell you what is this in the next slide, coming slides. I'll just showing you. So let's say you have a price, you have shipping cost, you have marketing, you have material. So these are all the inputs. So it does some processing here, and then it will tell you what's the demand prediction for a product, for a product. So so based on this output, see, if the demand is more, they can increase their price. If the demand is less, they can decrease the price and make it more available to the end users so that the sales will get increased. And with the demand in increase, with the price in increase, they have to spend more on materials, shipping costs. So with respect to the decisions that an AI is giving, the company is making lot of changes. See how dependent a application or a company is depending on AI just to give insights, just to give suggestions. So this is the real world state of the art technology, guys. That's where this deep learning and neural networks comes into the picture. And this is an example of unsupervised learning. See, I have told you, you have a basket which has lot of things. When you do unsupervised learning, it separates things. If you see, it separates things, it separates, and then it divides it. It divides into separate groups which are similar to each other, So we use unsupervised learning only if the information used to train is neither classified nor labeled. It's just a bunch of data, bunch of reviews of a book my show, bunch of reviews in a Twitter. We don't know for what they're talking. You don't know whether they're giving a positive review or negative review or a diplomatic review. You don't know whether it is an banana, apple, or a grape. So what does this unsupervised learning do? It didn't have any labels to study. It doesn't have any input labels. So it has to form its own input labels. It has to form its own output labels and then classify it. So the unsupervised learning is a study like how systems can infer a function to describe a hidden structure from an unlabeled data. Just see that definition, guys. So from an unstructured data, The unsupervised learning will try to understand a pattern which is hidden inside the data. It tries to get that structure and then it will classify. You guys are getting me? Are you guys with me so far? Guys, can you unmute your?
Yes.
Yeah. Thank you so much. Yeah. So,
But I got lost in the supervised learning one. If you can please go back a little bit after this one.
sorry, you want to explain which slide?
No, supervised learning.
Supervised learning. This one.
Okay. Yeah, can you just compare both so that we can get the difference?
Yes, I will do that for sure.
Okay.
So, you can if you have any doubts, you can stop me in middle or you can raise a hand. Anything I can see, guys. Okay, just don't wait for my call. You can stop me at any time, at any point. So this is unsupervised learning. So if you I'll just tell you an example. It's a data set of home prices where let's say the size of a house square feet 523. These are all the square feet 1034 2090, and these are the number of bedrooms and number of bathrooms. Is it newly renovated and what is the price? So now if you see, this is all your input data set.
So Tanmay, sorry to interrupt.
Yeah.
I mean, somebody wanted to understand supervised data. I mean,
Yes.
supervised data.
I'll
Oh,
come to
okay.
that part.
Good.
Yeah,
Sure.
I'll come to that part. Yeah. Yes, I'm coming to that. 1 second. Yeah. So input data set. This is all input data set. See, it is structured. See, this is a column, the column. These are rows. And each row has a label, which is an output. So this type of data set, which has a proper set of inputs and a proper set of output and a label, neatly labeled, this we can use only this for supervised learning. Supervised learning. Supervised learning is something that you can learn from a labeled data. From a labeled data. This is a labeled data. Unlabeled data is something that it doesn't have anything. Let's say you have a single row, single column, and then multiple rows. This is an unlabeled data. You don't know what to predict. You don't know what is the data inside. It is not structured. On this, we use unsupervised learning. On this, we use unsupervised learning. So the major difference is supervised learning will tell you whether it can predict a continuous variable and it can predict a binary variable. Like it can tell you, like as I just told you here, it can tell you whether it's a spam email or a correct email. It can convert an audio to text because everything is properly labeled. Everything is properly labeled, whereas unsupervised learning, it is not at all labeled. See, it's a group in this set of box. You have lot of fruits and you don't know what fruit is what. So you have to when you send this box of fruits to an unsupervised learning, it groups them with its own type and then it will label. First, see, it will take the similar ones and then next it will take the individual ones and then later it will name, this is of type 1, this is of type 2, this is of type 3, this is of type 4. So you give a bunch of unlabeled data and it ended up giving you a labeled one. So that's the difference between supervised learning and unsupervised learning. If the data is not labeled, you cannot apply supervised learning on that. If the data is labeled, if and only if, then only you can apply supervised learning and the other machine learning algorithms. I hope you got the answer.
Yes, thank
Yeah, thank you. So now you guys understood, right? The machine learning part, the supervised and the unsupervised. Supervised and unsupervised. So see, for both, uh, for supervised learning, when you build a model, you have lot of metrics to tell you whether your model is doing good or not, like precision, recall, F1 score. There are very new terminologies that we are going in deeper when it comes to the actual training part. But there are different types of matrices on which you can evaluate your model. Be it a supervised, you have different set of things. Even in supervised, you have two things. If you remember, one is regression and one is classification. Regression has some set of matrices. Classification has some set of matrices to identify whether the model that you have built is accurate or not. The same goes with unsupervised. It has some different set of matrices. Whereas neural network, it has some different set of matrices to evaluate. So for each type of algorithm, each type of its own machine learning kind, you have a set of matrices which will evaluate the model that you have done. And based on those matrices definition numbers, you're going to take a decision that, okay, this model is performing good on this data. So, and then you finalize your model. That's the flow, guys. Any questions here till here? The complete machine learning part. I have covered the whole part. You guys have any questions? You want me to repeat anything? Guys, can you unmute yourself and then just be interactive? If you have any questions, you can ask me out of the box questions. I'm open to answer. Uh, should I take the silence as no? Okay, cool. So next I'll just show you what is artificial neural networks and deep learn neural networks and deep learning, how they work, everything. So now, as I said, neurons, these are the basic thing that I said in our human brains, it is present. Neuron is something which is present in our human brain. They are also called neurons or nerve cells. So these are the fundamental units of a brain and the nervous system. So this neuron, it's a cell which is responsible for receiving a sensory input from the external world. See, I'll just give an example how the neuron works. Let's say you have your two hands. Okay, so you have two buckets in front of you. So the moment you kept your hand in a normal temperature water, and the moment you kept your other hand in a super hot water, let's say it's very hot. So which hand you'll remove first? Yes, I want an answer. Just try to answer. Just a basic question. You put your two hands into your water, into two different buckets of water. One is the normal temperature. Second one is it's a high temperature, be it a cold or be it a hot, high temperature. Which hand will you remove first? Just try to answer. Basic question. No, you can see my hands. And I dipped it into two buckets. So I just want to know which hand you'll remove first.
Surely the one hand which is on the hotter one.
Exactly. Why? Because the moment you kept your hand in the hot water, from the tip of your hand, you'll receive an immediate input to your brain saying remove. Because this has a more weightage. It immediately triggered your brain. So the same, it receives this very fast sensor input, and then your brain says you have to remove your hand, and it'll ask your body to remove your hand, and then you'll remove the hand. So it's a mechanism. Just think a human's structure. Your brain controls your body, just like your brain is like a motor, and your hand has a motor, your legs has a motor. So whenever your brain wants your hand to work, it'll switch on the motor of your hand, and like that. So why it will switch on the hand motor? Because it receives an input to do some action with the hand. So, and there is a scenario. Let's say, okay, if that is normal temperature, you can remove it slowly, because the heat, the moment you're sensing heat slowly, it will ask your hand, okay, you can keep for some time, and then you can remove. If it is too hot, then you will remove it very fast. That's the weightage. So the input that you are receiving from a sensor, it's telling how fast you have to remove. So that's the kind of mechanism that we have, and same mechanism, the neural networks, the neurons, everything in the deep learning neural networks, they have defined the same type of algorithm. So see, if the cells are responsible for receiving a sensory input from the external world, for sending motor commands to our muscles, and for transforming and relaying the electrical signals at every step in between. An artificial neuron is a mathematical function conceived as a model of biological neurons and neural network. So if you see this diagram, just understand this diagram. So this is your neuron. Okay, these are lots and lots of inputs. And if you see W, it's a weight. So these are all the inputs that it is sending to your neuron. So now neuron will process all your inputs. It combines all, like x1 plus x1 into w0 plus x1 into w1 plus x2 into w2 plus x3 into w3, and so on, like that. It aggregates your input, and then it gives you an output of what to perform. See, now just understand this little bit, guys. So if you see here, W is nothing but weights. So if this weight is more, then your cell will understand, will see this feature of more importance because the weight is more. See, this is how your neuron is giving importance to the feature based on the weight. If your weight is more, then first it will see your input, and then it will try to do. So that's the kind of mechanism, guys, that a neural network contains. So next, see, this is the overall architecture of ANN, means artificial neural and network. ANN means artificial neural network. Just 1 second. Let me just have my water. 1 second. I'm back. So artificial neural networks. See, this is an input layer. This is a hidden layer 1, this is a hidden layer 2, and this is an output layer. So you can have n number of hidden layers. You can keep another hidden layer here. You can keep another hidden layer here. It's based on the type of problem that you are solving. So artificial neural network is something, it processes the information. See, now let's see, this is an input 1, this is input 2, this is input 3. So what does it do? It kind of sends a signal to all the different neurons in our brain. The same thing it do the second one, and the same thing it do the third one. So it kind of process something, and it will ask the other neuron to process some information, and then finally the structured information come to this output layer, and then the output of this will be performed by us. the decision, the final decision is taken here. So this all process is the internal process to take a decision. Sorry, from here to here, this block is the decision making one, and this is where it gives you the decision, what decision I have taken based on the input. So ANN is something, it's just a mathematical model of the brain, which is which used to process non-linear relationships between the inputs and outputs, like human brain. Like let's say you watch a TV, you watch a phone, both at a time you'll do. So it does kind of a parallel thing. Sometimes by watching TV, you text something, you take decisions by processing an input from the TV that you're receiving, and from other end, you're taking a decision and giving it to some others in your mobile. So this kind of human terminology and technology is being used here. Okay, so now, so these artificial neural networks are mainly used for, let's say, self-driving
So
cars.
sorry, Tanmay.
Yes, yes,
So
yes,
what
Debashish.
I'm understanding is that is it a internal process of converting the unstructured data to a structured data?
No, it's not. As I said earlier, it might be a case, but since, see here we have proper inputs, which is a labeled one. So artificial neural network is something, it kind of gives you more importance to the features. So let's say the drawback of machine learning is, so let's say in machine learning you have a data set and you have a label. This is your supervised learning. So sometimes this only feature itself can give you a decision. But for machine learning, it will take all the features. We cannot say, okay, give more weightage to this input. You cannot say that to a machine learning model. But whereas in deep learning, based on, see, these are all weights, WW. So you can give more weight value to this input so that it kind of understands it. Look, I have to look more into this feature to take a decision.
Okay,
Now
got it.
yeah, so for unstructured, it's kind of, it'll do for unstructured, I'll just show you. So I have a simple thing, just text and all. So first what it will do, it will group, it will do a subgroups, and then it will have this. Now this subgroups becomes input, like this subgroups becomes input to your neurons. And then finally it will sell whether the review is positive or whether the review is positive or negative. So first it will do the for the unsupervised learning. If the data is not labeled, first it has to perform unsupervised, and then it should form labels. Then only you can do on this labeled data, you can apply machine learning, you can apply neural networks, you can apply all the other things. So the ANN, the artificial neural network, is more towards the labeled data, and it kind of performs a more deeper patterns. Like ANN is something, it understands more deeper patterns inside your labeled data. Okay, you understand the major difference now? Hello? You guys get it now? The machine learning, the ANN, the unsupervised, all the three categories. Guys, someone answer. Is someone talking? Hello? Can you guys hear me?
Yes, sir.
Yeah. So you guys are understanding, right? So guys, just give me a thumbs up symbol or something. It gives me motivation. Just try, no? Just unmute yourself and then express your feelings. So
Yes, sir. Understood.
thank you, Prashitosh. How about Mark, Janath, Mohan Prasad, Omkar, Gururaj? You guys are understanding things? Guys,
kind of sounds similar, but I don't know. I don't know if others.
sorry, what?
So it all sounds similar to each other.
Yes, just one step. As I said clearly, it's a subset. Machine learning is subset of AI. Deep learning is subset of machine learning. It's kind of looks similar, but the architecture and the types that make the data based on the data, you have to pick a type. These are all different types doing the same job, giving you the decision. But based on the type of data, based on the messy of the data, based on the deep understanding of the data, you will pick the models. So you're getting it? Cool. So
Yeah.
now, yeah. So now, so this artificial neural networks mainly used for self-driving cars, character recognition, image compression, stock market prediction, lot of other interesting applications. See, self-driving car, it kind of visions if there is a car or something ahead of you, it will try to slow down and then it will take you to the next destinations based on the Google Maps. Character recognition, like if you draw something, it will say it's an A, it's a B, it's a C, it's a D, and then what and all there in the image. Stock market, based on the trends in the stock market for each of the product, it will try to give you a prediction whether if the trend is going like this with the amount of time, at this time it may reach this peak. So this kind of market predictions it can give. Lot of other interesting applications that we can build using this artificial neural networks. See, how does a neural network learn? So I'll just show you how it will learn. So when a model is learning, I mean, when I say learning, it means being trained. Or if you after being trained, if the model is being used or something tested, the patterns, it stores the patterns of the data set that we have given. So see, this is your data. Okay. So it kind of process your data with a weight. So let's say this is your X1, this is your X2, this is your X3, this is your W1, W2, W3, W4, W5. So here you'll get X1 into W1, here you get X1 into W2, here you get X1 into W3, here you get X1 into W4, X1 into W5. It's a pure mathematical equation and solvings. I will tell the derivations, but it will be like interesting session after learning the basics of linear algebra and some statistics. It will be an easy crack for you guys. So it tries to understand the patterns. So what happens when you give a new input tomorrow? So it will come inside it and it will try to match this pattern with the patterns it has been stored. So you have lot of data, you send it to a model and your model understands some patterns, and then it is stored. Okay, if the data is of this pattern, you give this decision. If the data is of the other pattern, you give 0, like that. So when a new data is coming in, it kind of matches to a pattern which is more similar to each other, and then it gives you that decision. That's how neural network learns. It stores the patterns. It will try to match the pattern with the new input data that you have given. And once the pattern is matched, it will tell you, okay, for this pattern, this is the most relevant output. So it give you that. So this is how a neural network learns and gives you decisions. Okay. So as I said, it's the same for an artificial neural network to learn. It has to learn what it has done wrong and what it is doing right. I mean, it has to know both the cases. Like when should I give 0? When should I give 1? So all this it has to learn. It has to learn both the positive case, both the negative cases. Because see, let's say uh, you went to a hospital. So you have a claim you submitted, and then your machine learning processed and says it rejected. It says it's a reject, but ideally it has to pass. But it said it's reject. That means your machine learning has not given correctly. So then what? you're going to resubmit it again saying I have submitted all the documents, which is feedback. The one that you're upholding the decision of an AI is a feedback. So based on the decision that you have given, the model will relearn itself saying by adjusting some parameters, it will try to rerun and then it will tell you a correct prediction. So feedback is how we learn what is wrong and what is right. The same way the artificial neural network also. So this is where we see the similarities between a human brain and an artificial neural network. Like let's say if you're learning to play a game like tennis or chess or something, you learn move by move. You learn pattern by pattern. You learn step by step. The same way the ANN learns. In the same way the ANN learns. So this is how we learn and what we're doing correct or wrong. That is what a neural network needs to do, and then it will continue to do. Okay, it's the different type of learning, and in deeper learning, guys, artificial neural network is the state of the art for any data. So if you have a complex data set, just go for ANN. That's the top end. Okay. Yeah. So now again, neural networks, as I said, it's exactly the same way as the brain, as I said. So what happens? I'll just come back to here. Okay, I'll just come back to here. So you give you an input. It is coming till here. It is giving an output. Now you're giving a feedback. You're giving a feedback whether it is a right or wrong. So based on that, see you here you have a y. I mean the actual output, and you have predicted y hat. Let's say the prediction one. The both are wrong. I mean these both are not matching. So you just try to calculate the difference y minus y hat. The actual minus the prediction one, which gives you what? Error. So you send back that error and then it will adjust the weight of this feature. The weight gets updated here and then it will come back here. The weight gets updated and then it will come back here. The weight gets updated. Now my new weight will come here. You're understanding this pattern? See, I'll just try to give you 1 second. Wait, I'm sorry. Yeah. So now see, this is your thing. Okay. So now this is your input and this is your output. So now when you find out the error, which is y minus ya hat. So this error you give this feedback to your model and you adjust your weights. Your weights gets updated. So starting from here, all this weight till here, all these weight values will change. They'll come to new. The same way they'll come to new. All these weight values, every weight value will change, and then again it will rerun with the updated weights, and then it will give you a prediction again y hat. If that is still not matching, then you get another value error. Based on that, again you will do. So this sending of this error backwards and updating the weights, you call that as back propagation. Back propagation. So there is lot of partial differentiation, like how we gonna update these values. There is a set of lot of derivation. There is a beautiful max behind it. But when it comes to Python, 2 lines of code. That's it. So with the help of this back propagation, you will reduce this error between the actual one and the prediction one. So the more the reduce your error, the more the accurate your model is. So that's how a neural network learns. This thing a machine learning can't do. It's just simply learns it and then it gives you a prediction. But whereas in the neural network, you can change the importance of each feature. You can change how much it has to see, how much it should not it should not be seen. So all this internal patterns it will understand. Okay. So now see, this is what deep learning. As a deep see, if you see, I just showed you with 2 layers. See, it has almost like close to 1, 2, 3, 4. And this is also 5. Here you'll get another output, and then you'll see this is an output. Deep learning, as I said, see, deep learning is a subset of machine learning where this ANN algorithms, like which are inspired by the human brain and which learns from large amounts of data. If your data is too large, too complex, you have no other option. You have to come for ANN. So deep learning algorithm, like it will perform a task repeatedly each time by tweaking it a little to improve the outcome. As I said, see, it will try to improve its outcome by tweaking these weights, by tweaking, by doing a back propagation every time. It will try to re-improve itself, and then it will try to give a decision. So the name we give deep learning because the neural networks have various deep layers that enables the learning. Like any problem that requires a thought, right? Like to figure out how it can be done, like how a problem can be solved. So the same way these deep layers will understand the data. So because of this type of architecture, the deep learning allows machines to solve complex problems, even when using a data set that is very complex, device, unstructured, structured, interconnected. So the more the deep learning algorithms learn, the better the model is going to perform. Okay, so now there are real life use cases for deep learning. Let's say, I hope most of you guys watch Marvel movies where Freddy, the assistant of Iron Man. So it tries to give you a lot of decisions whenever the Iron Man asks. It will tells you what is the weather. It will tell you. It's like it acts like a virtual assistant, and it will try to translate. If you see the Wakanda Forever, the AI that sister provides, it has a translation. It can translate any language into our human understandable language, and then it'll tell you a vision like, okay, if you follow this pattern, it's going to come here like that. And then you have lots of chatbots which can do an automated tasks, and service bots like where they can tell you how to do what to do. Recently we have Buji, the assistant of Kalki, Prabhas new movie. I hope you must have seen. So these are all some real life examples that you can see in TV. Like recently a new movie got released in Netflix, Atlas. It's a pure in AI. How AI can be more dangerous. Just go and watch that movie. It'll clearly shows you how AI can interact with a human, or how it can learn by itself with the data that we have. So there is a lots of, and I'm saying AI is more dangerous if you not use it correctly. Just this is a statement given by Elon Musk, and it's true. Okay, yeah. Uh, and it has some other things like, let's say,
Sorry,
yes,
Tanmay, there is a question from Rishabh regarding,
yes.
sir, can you please share the PDF in the group? So
Yeah, yes,
yes,
I'll be sharing them in the group.
actually, Rishabh and others, whoever has registered to this program will be, you will be accessing those links, and also the content will be there on the on your registered learning path. Okay, so don't worry. Each and every word that is mentioned over here in the form of PPT is available in your day 2 session of AI. If you visit our site, it will be there because you are registered already. Is that fine?
Okay, sir.
Yeah. Thank you. Sorry, Tanmay, you can continue, please.
Yeah, sure. So With there are other more deep learning cases like image colorization, facial recognition. Like it can tell you, okay, based on the face, it will tell you what's your name and all these things. It can tell and uh, like what medicine can you suggest for it, this type of treatment, pharmaceuticals, and personalized shopping. The movie recommendations in Netflix itself is an AI. Like I'll just show you. I'll just tell you how the Netflix recommendation helps you guys. How it's interconnected, I'll just show you. So you are a user of Netflix. Okay. So you watch some movies, some genre. Okay. With the email, you are a friend with you're another friend who has a Gmail. So with the email mapping, whatever your friends see, so since you both are friends, it will think that, okay, we can recommend. Since you have also watched the same type of genre, it's going to recommend you. Or if you watched another thing, it can trigger you. You can try this watching. So this type of recommendation system the Netflix has, it's a very complex. In the whole world, the Netflix recommendation system is the complex one. It will take some time to crack the code behind it. So ANN, it's like only three layers, like the input layer and the hidden layer and the output layer. Input layer, hidden layer, and the output layer. So and whereas and these are fully connected networks, like fully connected layers, like as I said, like no, come here, 1, 2, 3, 4, 5, and 6. So these are a fully connected layers. So and there are hidden layers, everything. So deep learning is as I said, no, it's a self-teaching and learning, and then it goes forward propagation, check for an error, backward propagation, the way that I explained. So apart from this, there is one more thing called DNN. It's the deep neural network. Both are same. ANN and DNN both are same. But what does this difference? It's so simple. Deep neural network is something, it will have interconnection. I mean, ANN also have the interconnection, but just that the updation of weights, like till where you have to stop updating the weights, and okay, I'm making enough decisions. So this kind of small things, one function, see this function rely on this function rely on this, like this interlinks, right? This is majorly DNN. It's both are same. If someone asks you what is ANN and DNN, it's both are same. Just deep learning is deep neural networks are something very similar to humans, and ANN is mainly made up of input layer, hidden layer, and output layer. And if you have, see, if you have one hidden layer or two hidden layers, it's ANN. But whereas inside the hidden layers, if you have more deep layers, that is for deep neural networks. Okay. Yeah. See, it's just the thing. Input, and then you'll do. A man will sit and will do the future extraction, and then it will send to a neural network, and then it gives you an output. Whereas deep neural network, it kind of take care of future extraction, classification, everything based on the input. So this is how the major difference, like between a deep learning and a machine learning. Machine learning kind of a person needs to develop, as I said, no, like it has a labeled data, and then you have to do. But whereas deep learning, it can be done in a single go. The deep learning will understand the patterns inside the feature, and then it will try to classify, and then it will give you an output. So that's the major difference between deep learning, machine learning, and the other technologies. So see, this is, if you have only one neuron, we call this as perceptron. Only one neuron. If you have different neurons, like let's see, this have different neurons. We call this is a fully connected layer, and we call this as a neural network. Neural network is something, it's a network of neurons. Initially, it was developed in 1969. This is not something achieved recently. But at that time, you don't have enough compute system or something. So what they do, they used to do maximum with only one neuron or maximum with one hidden layer. But now with the increase in the compute capacity, storage, the infrastructure, we can do wonders. And this is the other type of deep neural network, which is called CNN, which is called convolutional neural network. Which is convolutional neural network. See, convolutional neural network is, see, ANN is a brain which has neurons, whereas CNN, it's a vision. Like in your eye, if you see, there is a black ball which has a visual, we call it as a visual cortex. It makes use of this visual cortex. So first it'll try to see, let's say you take any image, the convolutional neural network, it will convert this image into 0 to 255 pixels. It can understand only red, green, and blue. That's it. Only these three colors it can. So whatever the image that you send, there are different kernels. There are different kernels. Let's say, see, you have a matrix with 0 to 255 defining your input image, and you have kernels like vertical kernel, horizontal kernel. So when you do a matrix multiplication, if you get a proper value, that means okay, there is a vertical line, there is a horizontal line, like that there is a face kernel. When you multiply it, so okay, here there is a face. So this is how a deep neural network understands the image. So it will take the input, see, it will try to map one part, it will do the convolution with the kernel, and then it will identify and keep it at one part. So the same way it takes here, it will do the kernel, it will place here, it will take here, it will do the kernel, it will place here. So this kind of visual cortex and converting any image into pixels and then doing it um, is something a convolutional neural network will do. So there is a theorem. I kept this to just to make you guys comfortable with the mathematics of the statistics. So the universal approximation theorem states that neural network with one hidden layer can approximate any continuous function for inputs within a specific range. So this means, see, you have one neuron. There is a function you had it. So with this inputs in a specific domain, very limited range, one neuron will be sufficient. So if the domain is increasing, if the range is increasing, the network has to increase. So the graph goes like this. That's what this says. Okay, just a basic definition I'm just saying. Now, this is the state of the art technologies that are there. The advanced part of deep learning are GANs. GANs are nothing but generative adversarial networks, which is GANs. So basically, these GANs are nothing but generative modeling. Generative modeling means using deep learnings, let's say artificial neural networks, convolutional neural networks. It generates the output just like how you want. The chat GPT is a generative model. So based on the input that you give, based on the prompt that you give, based on the image that you place in the chat GPT, it will give you. It will give you. And it doesn't has to be of specific domain. See, that is why generative modeling is an unsupervised learning task because it doesn't have any labels. It does not belong to any domain. Just you giving a random input. It itself, the GANs, what it will do. So based on the input, it itself categorizes into which department this in prompt belongs to. It kind of checks everything, and then based on that, it picks one type, and then it will give you an output in that type. So this is what GANs are. I'll give you more detail about this chat GPT in the day 4 of this AI internship live session. So with this, I'm going to stop here the theory class. I have clearly stated you what is machine learning, what are the different types of machine learning, and what is deep learning, what are the different types of deep learning, how is machine learning and deep learning are separate, and inside the deep learning, what each type does, inside machine learning, what each type does. So this kind of whole picture I have given. Hope you guys understood this. Yes, please give me some thumbs up, something, just a motivation. Or if you want me to repeat something, I'm going to repeat it. Before I just show you the practical coding part, I just want to reconfirm how this is going and everything. Thanks, Debashish. Guys who joined late, I suggest you see the recording so that you'll get interconnected, just like how the neurons connected. So everything is cool. So can I proceed further into the practical sessions? I'll just show you overall picture. Is that fine? Guys, please
Yes.
respond.
Yes,
Yes,
yes, you can.
Thank you so much. Okay, you guys able to see my screen? Guys, you guys able to see my screen? Yeah, cool. So I'll just show you. I have a customer mall data set where I have a customer ID, gender, age, and what is his annual income and what is the spending that he has done. So I have this data from a mall customer or something. So now how are we going to approach this? So first, see, these are all the data science modules like pandas, numpy, the one that I have told in the day 1 live session, the cbon, the matplotlib. So you have to when you say shape, that means see it has 200 rows and 5 columns. This means you have 200 data points in a data with 5 features. Now, when you say give me the information, info means give me the information of the data sets it is giving. OK, you have a customer ID which has no null object and it is of data type integer. Gender, there is no null in the type of object, and then age, int, annual income, spending score. So now you imported a cbon. So this is how you import data science algorithms. Import cbon and then you'll try to see. OK, in my data set, I have close to 80 male and above 100 female. This is an insight. We can see the number of females is more than the number of males. Obviously, right? Shopping malls, everything, ladies, they'll only take us. So now let's see in this how many people belong to different ages. You see, there is a lot. Age 0 to 8, 0 to 8. So the labels are not clear, right? So let's zoom in. If you see here, under 18 age, there are 3 people of male and 1 female. From 19, you have 6 male and female. And if you see at 30, 31 age, the females are too high. So the first range, if you say 27 to 38, the second range is 47 to 50, For the age group of 18, 19, 20, the number of males is more than the number of females. So this is the insight that you're getting. Nothing you're doing, just you're understanding the data. Like, okay, how many males came, how many females came, and inside that, okay, how many males of what age type they are coming. And let's see the annual income. Let's say a person with 15 age and let's say 61. So no, with it's annual income, right? Sorry. So with $15 as an income, there are two people, and which has more of 54, there are 12, and 78, there are more 12. So this is a kind of uh, annual income bar chart. Like there are different types of graphs, guys, that also we're going to discuss in the trainings. Like based on each type of feature, what graph can you draw, what insight can you get. So there is a common complete session dedicated for that. uh, Next is something, see, this is based on your customer age, annual income, and the spending time. So if you see for each thing, see, let's say uh, the male, if the blue line says male and the red line says female. So the in each and every aspect, say because of the based on the customer ID and based on the age, based on the annual income, so it's everywhere. The gender is not much differentiating factor because everywhere it's very close. Men and women both are like very close. So we cannot do anything with respect to gender. So we can drop that. Since you don't have any use, like you can like since like this is a female, this is a male, you cannot predict something or you cannot give a decision something. So you can drop that. Secondly, the customer ID, that also is of no use because it's unique to each person. So the customer ID is also no use. You can also drop that. So like this, you have to take your own decisions when you are playing with the data. And the decisions that you take on a specific data is the ones that going to create an impact on the data science model that you're building. Okay, so you're dropping both the things. So now you have become age, annual income, and spending score. Now, so see, this is a data set. You have age, you have annual income, you have spending score. Now, do you have any label here? What to predict? What to predict? Do you have anything here? No, right? You don't have anything to predict. So what can you do? What will you do here with this data, which is of no label? You have an age, you have an annual income, you have a spending score. What I can draw with this information? What I can draw with this information? Just can you guys give it a try? I am giving you a hint. It has no label. So which one to proceed? Supervised or unsupervised? Guys, just try to give an answer. Supervised or unsupervised? It has no label. Which one should we go?
Unsupervised.
Perfect, perfect. So now there is a K means is a clustering. Unsupervised means I told it's a clustering. That means it is grouping. So it tries to this is a code which will group. See, this is a group, this is a group, this is a group, different groups. I'm going to tell you what each represents what again. So now you're just plotting this thing. So now see, if you see here, there is a clinch at this point. At this point at 6, you have a dip, and at this point you have a dip. At cluster 3 and at cluster 5, you have a dip. You can see two dips at 3 and 5. So you can go with either grouping this data into 3 or grouping this data into 5. This is how you're gonna decide how many groups you have to do your data into. So let's take 3. Let's take an example of 3. So now after you divide this data into 3, you see it became 3. This is 1, this is 2, and this is 3. You see 3 different colors. This whole thing became 1, and this is 2, and this is 3. It divided your data set into 3 different groups. 1, 2, and 3. Now, if you make it to 5 clusters, if you see this is 1, this is 2, this is 3, this is 4, and this is 5. So this is how you group the data. Now you can see, okay, people are ranging from 40 to 60. They have a spending score of close to 40 to 60. So where you have less data, from 20 to 40, you have a less spending. So you concentrate more on this people where they can come and they can buy. This is how you take a decision from a clustering point of view. So you guys understood, right? The decisions or the insights that we are going to draw from a thing. This is an example of unsupervised learning. So let me show an example of supervised learning now. So I'm taking an restaurant data set.
So sorry, Tanmay.
Yes. Yes.
What is the decision which is coming out from this your plotting? The annual income versus the spending pattern.
Exactly.
Do I have to? What is my target group?
Here your target is the audience. See, if you see where it's less based on the spending score, which annual income group is less? Which group is less? The greens or the yellows or this purple or the reds or the blue? So based on the spending score, wherever your data is lesser, you try to concentrate more on that data set to bring more people to the mall. Okay, so let's say if my annual income is only this, he can also come to mall. How are you going to make him come to the mall? So first, how are you going to decide to whom you ask to come? So that kind of decisions that can interfere. This is a small example. So sometimes, okay, right. from this we can also do something like, let's say, okay, this is of type 1, type 2, type 3, type 4, and type 5. So the green peoples are most likely not to come 0, 1, 1, 1, and 0. So now you have labeled your data set. So tomorrow, when a group of person comes like with an age of 19 with an income this and with the spending score of this, it will try to make that person fall into any of these groups, and then it will tell you whether he can buy or he cannot buy. So that is a decision. Did you get it?
Yes, then. Yes.
Yes. Thank you. So now let me give an example of supervised learning. So I have a data set of let's say restaurant revenue prediction. Let's say I have a date, city, or what is the city group does it belongs, and there are different types, and there is a lot of data if you see. And what is the revenue? There's a lot of data. You don't know what to do with this data. So first you checked how many rows, how many columns, and then you say what are all the columns: ID, open date, city group, type, P1, P2, like that, P37. So this, what is P1, what is P2? This you get from the subject matter experts. So I'm just going to tell you. So now this is of more like, let's say based on this, if you see 4 of future types are object which the model cannot understand. So like, let's say the ID, this zeros and ones, and this date, model cannot understand with the date. So there are things like different things. So now we have to see this date, it cannot understand now. The model cannot understand. So there is a date time format in the Python libraries which is available. So you can extract month, date, year from this structure. And then if you see here, this is your open date now. Now if you see this difference from 0/17/1999 to 1999-07-17. So from this you can extract month, year. If you see city Istanbul, and if you come to the end, see at what month and what year. Now when you have 2 columns extracted from an open date, no need of this open date, right? You can drop this. So after dropping, now you have make your date column available. So in this month, in this year, this is the revenue. So now you can draw KPIs from this month to this month, from this year to this year. This is the revenue. These are the types. So these kind of data analysis that you can do. So guys, don't get confused. when you keep your hands on the data, you will do more. So now if you see based on the month, I'm just telling the count of people that are coming and all we can do, like what is the mean of the revenue for each month. So this is this kind of graphs that you are going to draw. And based on that, see if you see type, there are three types: FC, IL, DT. Even I don't know what are those, but this FC, IL, DT, these things a machine cannot understand. So you can convert them to FC means 0, IL means 1, DT means 2. So now they became 0, 1, 2. Now your type became C 1, 1, 1, 0, 0, 0. So now your complete data is of numerical types and your revenue, your month, your year. So now based on this, you have to predict, let's say, what is that you're going to predict? Okay, so you have to predict revenue from all the other features and the month and the year. Given all these things, you have to say how much revenue you're going to get. So now see, I'm dropping my revenue column and keeping everything into my X. If you see, out of 43 features, 42 are in my training data, and only for this 42, my Y is my label. So your X, your Y, both are label. So now you can go for the supervised model. See, linear regression. So all you have to do is like just dot fit X train comma Y train. So X train is your complete this data set. Starting from here to here, it's a data set, and Y means your revenue. So when you do fit, when you say fit, where is this? Yeah, when you say fit, it will understand the patterns in all these things, and then it'll, based on this revenue, it'll understand a pattern. So now if you see, I'm doing a fit here now. See, I'm importing a matrix. See the ME, the mean absolute error, mean square error, R square error. So these are the things that we do for a regression model. Okay, now if you see dot predict, dot fit, dot predict. Even if you see here LR dot fit, LR dot predict. So dot predict means you have divided this complete data set into two things here: training data, test data. So on training, you do dot fit, which means it understands the complete patterns inside your data and then based on the revenue. Now test data set, your model doesn't saw the test data. So your test data has revenues. So when you send this test data to the model, when you say dot predict, if you see clearly here, see, I'm train test split. So see, when you say test size of 30, I am taking my training data set as 70 and testing data set as 30. Now I'm training my model. I'm training my model on the 70% of data, and I am predicting on 30% of data. So now if you see, this spread has the revenue values for this X test, and the Y test is the actual revenue values, and the spread is the prediction revenue values. So you can calculate the absolute error, you can calculate the squared error. Based on, see, if you see here, the absolute error is very high. The mean squared error is also very high, and R2 square is in minus. So this model is not doing that great because your errors are too high. So come to another model, decision tree. This is also have very things. And whereas random forest, see, this also has some things. K nearest neighbor, see, it is kind of reduced with mean absolute error, and R square also it came to minus 0.2. Whereas XGBoost, if you see from all these models, the random forest gave you minimum error 1542. Here you see 17 and you see 21, 26. So for all the models, this random forest gave you less error. So that means this model is good. For all the models, RF regressor gave minimum error. So the best model should be chosen as the final model. So based on the matrices, based on the different types of things that you do, it's in everything it's same. See, dot fit, dot predict, and the metrics are same. The numbers are going to change. See, dot fit, dot predict the metrics, and dot fit, dot product metrics, dot fit, dot predict metrics. So this is just a 5 lines of code, but behind this 5 lines of code, there is a lot of max. So you guys understood this is how we do the real coding. We build real applications. So I hope I have covered the complete agenda for today. So you guys have any questions or anything? I'm open to question and answers now. You can ask any questions. I'm just stop sharing my screen. So I just want to guys you to open. See, it's a day 2, and we have covered most of the topics like the data science. The 60% of these topics, like if you can learn till here, and if you're able to code by yourself, you can call yourself a data scientist, junior data scientist, or just a machine learning engineer. So these are some roles that can suit you very well. Okay, guys. So any questions so far? Anything? Just bring it on. You have any other query related to apart from this training in this domain, in this knowledge? You can ask me anything, guys. I'm open to answer. I have 10 more minutes. Guys, pick up. We can have a casual talk. Let's just throw it up, whatever you have in mind. You can ask anything. Just tell your state. I mean, like where are you currently? Why are you interested in this? If you have any questions like this training place you where, just give me a background of yourself. I can guide you. I can just give an answer which can solve some questions. So I'm open. Okay, let me stop my recording since it's okay. I stopped my recording as well. So you guys have anything?
Tarmay, I can say one thing is within these 2 sessions that I had with you, first of all, it is thank you for the brilliant sessions.
Thank you.
See, without knowing anything, I just jumped into this session and tried to understand from my level of understanding of what we are going to expect. It is so fascinating. It is so interesting. And the way you have presented the 2 day sessions, I also being a trainer myself, I also feel excited to get into this domain to at least learn what is happening around me. So it's really, I'm really, what should I say? I'm really thankful to you to
Thank you.
give
Thank you
me
so
that
much.
insight. You know, there's so
Thank
much of things.
Yes,
Uh,
yes. And see, AI is not just a with a boundary line. It's like the more that you learn, the more you get placed, the more you get high packages. Companies will fight for you. Trust me on this.
exactly.
My yes. So people are removing jobs because of AI automated, but A- no one can automate AI itself. So your job is secured in AI domain. So any
Yeah,
questions, guys? Yeah,
that's a very valid point. I mean,
yeah.
you have the
Thank you,
ultimate
thank you,
knowledge.
thank you,
So
Debashish. Yeah.
yeah,
So
I don't know. It's unfortunate that we are not getting that much of. I mean, the number of students attending your sessions uh, is not that much, but that's okay. Even if
yes, yes.
one student can get some impetus, some inspiration from your sessions, it is a success.
That's what my goal was. At least I have to make one student get inspired. That's my
Yes,
goal.
yes,
Yeah,
that's it. That's it. That's it.
yeah.
For trainers like us, it is that much of inspiration is more than enough.
Yes, exactly. Yeah. I
Just a
think
quick question I want to ask. It's like where I can do the hands-on for this, like where I can do real time, like or some kind of scenarios and study base uh, things with the AI machine learning.
very good question. Thank you. So you have different Python tools like Visual Studio Code, and you have Anaconda, Jupyter notebooks where you can load your data and then play around with it. And you have different algorithms, and you have to pick the right algorithms, the right module for right type of data. Let's say if your data is in CSV, you have to write read underscore CSV. If you have an Excel, you have to write read underscore Excel. If it's a zip file, you again have to you have to say read underscore CSV, but with an extension of zip file. So you did something. You reduced your data to 2 to 3 features, and you have to store it. You have to again write it back to CSV. It's a Python. The source, the major, it's Python, and you have lot of two softwares like Visual Studio Code, PyCharm, Jupyter Notebook. These are some of the softwares that support Python language, and you can do wonders in this.
Thank you.
Yeah, cool. So yeah, I think we are good. So let's meet again next week with the third session on the super important topic, the natural language processing. Like how it's the major, right? Like the chat GPTs, the Siri, the Google Alexa, they're all NLP bots where it will understand the human voice. It will understand what a human is saying. Let's say if I'm saying it in a good way or in a sarcastic way, how the machine is getting it. So that's the beauty behind NLP. So we'll see it in the next week. Happy weekend then. Bye bye. Cool.
Thank you, Tanmay. Thanks a lot.
Thank you.
Thank
Thank you.
you.
Thank you.